Okay, so now, we want to spend some time on the tuning the large language model. Like I told you guys, when you do the GPT do not always give you satisfactory answer. Sometimes they give you answer you think is not correct. So how to tune GPT to give you the answer you want and understand your unique needs. That's what we are trying to focus on here. So you can see you can see the model increasement, right? So the GPT start from 1.0, 2.0, and then you can see that the GPT become bigger and bigger. The model become more sophisticated. So for the GPT-2, you can get all the parameters and the code of the GPT-2. So, but before GPT-2, you can get all the parameters of GPT-2. So after GPT-2, they don't share anything else. So you don't know anything about the GPT anymore after the 3.0. So this is an interesting fact, right? OpenAI was created as a non-profit. Supposed to OpenAI means what? They want to make AI open to everyone. That's the purpose of OpenAI, right? So for the GPT 1.0, 2.0, they are doing that. But once they become powerful, the OpenAI become not accessible for many of you guys. You have to pay $20 to subscribe, for time to subscribe. But instead of the Llama become free to everyone. That's interesting. Llama is by Meta, supposed to be a profit-driven company, but they are offering free language model for you. So the world is very more interesting than what we expected in the past. So you can see that the model has been evolving. So I give you guys an example. Why are we trying to fine-tune the model? Well, let's give you guys an example. So this is a question you want to ask GPT. So you ask GPT, what's the change in the compensation of Apple CEO over the past 3 years? That's the question asked. So you compare how to get the answer. Use Google search. Terrible, right? You just don't get anything you want. And use GPT. I use the earlier version of GPT. The answer is very bad. So, I'm sorry, I don't know how to do that. But if you fine-tune GPT, you fine-tune this, the GPT can give you exactly the answer you want. What's the percentage? You can see the answer is very organized and structured. That's what you want, right? So we will do a lot of exercise on this. You guys will do this, how to tune the GPT, to make GPT to give the answer which is customized to your unique needs. So, but you can see the example here. Google search does not work. The original GPT does not work. But if you tune the GPT, GPT will give you the answer you want. So how to tune that? That's what we're going to focus on. Like it's stuff. So let's use a more simple example. I don't want to overwhelm you guys. Let's use a simple example. How we tune the GPT. So this is the setting I want you guys to do. So basically, I give you a conference call. Give you a conference call transcript. And let's say the conference call have 10 sentences. So you ask a GPT to tell which sentence is climate related, which sentence is non-climate related. It's a very easy task, right? You give it GPT 10 sentences, and the GPT tell you which one is climate related sentence, which one is non-climate related sentence. And you ask a GPT to answer the question. So these are the setting. We want to use an example. So very straightforward, very straightforward. And then, so how you can add GPT, give the answer you want. You have two options. The first option is called prompt engineering. The second option is called model fine-tuning. And then the third one is called unstructured tuning. There's three options, but most people focus on the first two. And let me give you a concept, the options you have, and what option is easy, what option is difficult. So what does prompt engineering means? Prompt engineering means you don't change the knowledge of the model. You just give them the additional cheat sheet. And the model can use cheat sheet to get the answer to you. And what's the fine-tuning means? You have to change the knowledge base of the model. You have to change the parameters of the model. And then the model can answer the question for you. And the instruction only means you have to give feedback to model. And with your feedback, model can do better. Okay, these are the options. But let me use a more plain English, tell you guys what is going on. So let's say you use Llama. The reason I use Llama is because you cannot fine-tune GPT. Because GPT, they didn't disclose their parameters. You cannot fine-tune GPT. You can only fine-tune the parameters you already disclosed to the public. So open source large language model, you can only fine-tune. You can only fine-tune open source large language model like Llama. So these are the some things. So let's use Llama as example. So So let's say you want to Llama to the CPA exams. You want to use Llama to the CPA exams. So you have two options. The first option is you give Llama a lot of CPA examples, just put in a prompt. And then with that prompt, Llama use that prompt example you give and answer the CPA exams. That's the option one. The option two is what? In that case, the parameters in the Llama didn't change. Llama is still Llama. Llama is still Llama. You didn't change anything about Llama. You just give Llama some cheat sheet. Llama uses the cheat sheet to answer the CPA exams. That's the option one. Okay. Whereas option two is you use the exams as a training sample to change the parameters in Llama. You change Llama. So in that case, it's not Llama anymore. It's a counting Llama. You have to change the parameters in Llama. So it's not just simply give cheat sheet. You have to have the students to take 10 courses to change their knowledge base. And then that's the second option. Okay, that's second option. So you can see that the first option is what? First of all, if you think Llama is a PhD student, let's say Llama is a PhD student, the first option is you just give the cheat sheet to the PhD students, and the students can finish the CPA exam. That's the first option. The second option is you have the PhD students to take a 10 accounting course, to do all these exams, and make a accounting PhD. And the accounting PhD will finish the CPA exams. So this is option two. And option three is you just give them feedback. You are wrong about this. You are correct about this. But let's focus on the first two. The first two have some other options called hard tuning, soft tuning, and p-tuning. These are we talking about. And even for the fine tuning, we have the prefix tuning and the fine tuning. So we rank this by what? We rank this by easiness. What option on the top is easy to do. Whatever in the bottom is difficult to do. So remember, if you give a cheat sheet to the Llama, if cheat sheet can do the job, that's it, done. If you give a cheat sheet to Llama, cheat sheet cannot give you a satisfactory answer, and then you have to go to more difficult decisions. So you can see we rank the options by the easiness and the cost of this implementation. So we put the easiest one on the top, the difficult one in the bottom. And I can tell you, most of you guys, I think you up to here. The prefix tuning needs some programming skills. So we don't cover that in the class. But all this above is easy, straightforward. So as long as you can master this prompt engineering to help the GPT understand your unique needs, you should be good. For this model fine-tuning, you just understand the concept because that requires little programming skills. So that's what we are going to cover and emphasize on. So let's see what we have here is 0 shot, 1 shot, and few shots. So what does that mean is for 0 shot, it means you don't give any example to GPT. Just ask GPT, tell me, what is climate-related sentence? What is not climate-related sentence? Remember earlier example? And what is 1 shot? You give the GPT 1 example. This is climate-related sentence. According to this example, can you help me to classify the rest of 10 sentences? That's 1 shot. So what is a few shots? You give more examples to GPT. GPT will give you an example to classify the remaining 10 sentences. So you can see that we have a 0 shot, 1 shot, and few shots. Like it depends on how many examples you give to them. So this one doesn't change the parameter of GPT. Do not. This is just a cheat sheet. The first one is don't give any cheat sheet to GPT. And the one is just give 1 cheat sheet. And you give 10 cheat sheet. So it depends on how many cheat sheets you give GPT. And GPT can answer the questions for you. So these are the... So when do you use 0 shot? When do you use few shots? Of course, if your answer is very easy, you can tell if some answer is like say, let's say like can tell me which is dog, which is non-dog, like this kind of sentence. Like GPT can of course do this. So if your question is very unique, some have a lot of domain knowledge, and that means you have to feed more examples, right? So whether you need examples depends on your question. If your question is common sense, you don't need example. 0 shot will do the job. If your question is very domain specific, and you need more examples to fit into GPT, right? That's the idea of this. And then, so what you do here is, what you want to do is, first, you want to do the, let's say your GPT or large language model. What you want to do is you first create an account because the account can memorize your prompt. So each one have an account. So basically you can create an account, and you can create an account and get access to the large language API, and or you can use just web access. So so for this course we don't use API, just makes things easy. But you will know if you just do 10 sentences, you can use the web page to do the 10 sentences. Let's say when we process data, I have like 10 million sentences. If you 10 million sentences, you have to manually do that. It's impossible. So you have a massive data, you have to call API. API is similar to what you guys use in the ChatGPT, but API can friendly process the massive data. So this is the API. So what do you put into the large language model? So what you put in is, so you put the 10 sentences, and then you tell GPT, I want climate-related sentences, and you give them examples. So that's what we need, and then you can give more examples if you want, and you can evaluate whether they do it well or not. So you can see what's the input. The input is the 10 sentence from transcript, and you ask them to classify this is climate or non-climate, climate-related, and then you have examples. You give them more examples, and then you want to test. You want to test the model, whether the model is good or bad. So this is the prompt you can use, and you can see how you do the prompt. So you can see that you first define the role. So you can see you are an AI analyst to help identify climate-related sentences from conference call transcript. Please return 1 if the input data is climate-related. Please return 0 if the sentence is not climate-related. And you only provide 1 or 0 as the answer. And then what you do is you give the sentence, and the GPT will tell you this is 1 or 0, right? That's the prompt. That's the prompt. And you can see there's several things you need to do. And we'll talk more about it in the exercise. Define roles. You have to tell you are the analysts. Because when GPT knows you are an analyst, they will make a judgment, act like an analyst, right? You have to define the role. And you have to define the task very easily. 1 is what? 0 is what? You have to define that very, very clearly. The more clear you define the prompt, the more clear answer you will get. And why I want to say only provide 1 or 0 as the answer? Because the hallucination of GPT. If you don't put that sentence, GPT will tell you, oh, I'm not sure what do you ask about. This may be climate, maybe not climate. This is the explanation. The GPT will give you a lot of some explanations you don't need. So in order to eliminate hallucination, you want to make the prompt clear. You want to tell GPT clear what do you want. And then you give the sentence, and it give you the 1 or 0, right? Oh, the question is, what if they give you, this is definitely clearly, this is climate related, right? What if GPT give you 0? Right? GPT is sometimes not smart enough. What if it give you 0? That means GPT is doing wrong. So what do? Easy way, just one shot. So you give a sentence, say, okay, GPT, this is the climate sentence. I label as 1. According to this example, can you tell me what's the new sentence? Is climate or non-related, right? So from the prompt engineering, you give 1 example, and the GPT can use the first example to give you the right answer. But what if it still is not good? You give 1 example, it's still not good. What do? You give more examples. So you tell GPT, okay, this is a climate-related sentence. This is non-climate sentences. You have 2 examples. Can you tell me whether the new sentence is climate or non-climate related? So you tell GPT more examples. GPT can answer the correct answer for you. What if it's still not good? Give more examples. What if you give them a million examples? Still not good. So we have to do the second option. So the first option is what? It's called one shot to few shots, right? Give more examples. Give more examples can help GPT answer it. But even if you give you more examples, the GPT can still give you good answers. What do? Then you have to you move on to next step. We call prompt chain of thoughts. So what does a chain of thoughts means? Means you guys use cheat sheet when you do the exams, right? You guys do use cheat sheet. So when you guys use cheat sheet, it depends on how well you organize the cheat sheet. If you just organize the cheat sheet in a bad way, it will not help, right? But in a cheat sheet, if you can highlight what kind of information is important, what kind is not important, that highlighting will help you to do better using the cheat sheet, right? So the idea of prompt engineering is what? idea of prompt engineering to be simple is how you can make your cheat sheet informative to GPT, and make your cheat sheet organized to GPT, and make your cheat sheet highlighted with highlighted feature to GPT. So all the prompt engineering is not about tuning the model, it's how to make the cheat sheet informative, organized, and highlighted. So that's the philosophy of prompt engineering. So it's different from earlier we tune the model. It's about tune the prompt. So I hope everyone gets the idea clear. So when we do the prompt engineering, we are not tuning the model. We are tuning the prompt. So it's like a cheat sheet. How we make the cheat sheet more organized, informative. How do you highlight what's the important information in the cheat sheet? That's the whole thing about prompt engineering. Okay? If that is not working, now we move to next step. We have to fine-tune the model, but we don't want to go that far. Because to go that, it's a little bit, you need technical skills for that. So we don't want to go that far. So if this is not working, what do we do? So one thing is called feature selection. What does feature selection means? It's like in the cheat sheet, on the cheat sheet, you can highlight this point is important. This point. So basically, you highlight the important knowledge on your cheat sheet. That is feature selection. So what do we do here? So for example, so you give the GPT the example. This is a climate sentence. This is a non-climate sentence, right? You give the example. You also give the explanation. This one is climate sentence because I see the word climate risk and I see the word sustainability. Because of the words, I've identified this is a climate risk, climate sentence. And you tell GPT, I don't think this is a climate sentence because I don't see any related things in the sentence. So on the cheat sheet, you just highlight the climate risk. You just highlight this, and you just highlight long-term sustainability. You highlight this information. Make GDP know what's your logic over just what's your logic. So basically, the number one rule, if the GPT doesn't give good answer, is to highlight the important feature to GPT, and the GPT will rely on the important feature, make a better performance. Produce better performance. So that's number one. Number one, you should try. Okay. So you see, to summarize, first is what? Give more examples, right? Give more examples. That's number one. Number two is what? Among the examples, you highlight what's the important feature to help you make a decision. Okay. So basically, in example here, you not just give the 1 or 0, not just give that. Explain. You give 1 because of certain keywords, and then GPT will do better job. But what if it's still not working? What is still not working? So this is a chain of thoughts, which is overlapping with what I just talking about. So look at these math questions. So Roger has 5 tennis balls, buy 2 more cans, blah, blah, blah. And give you GPT, the answer is 11. It's one shot, right? This is one shot. And you ask GPT the math questions, and the answer is 27. Because GPT just doesn't get this one shot. However, if you change the answer before you put the answer, the answer is 11, right? But if you write down the logic, you say the answer is started 5 balls, 2 cans, if you write down the logic, how you get the 11, you write this down, GPT will give you the right answer. So this is a chain of thoughts. What does chain of thoughts mean is you not just give the answer, you give the reasoning, how you arrived at the answer. And the GPT will learn the reasoning from you and give you the answer. Beautiful, right? It's beautiful. So again, going back, the philosophy is not tuning the model. The philosophy is make the cheat sheet informative, organized, and highlight the future. So you can see that. No, so you can see that now you have 3 options. If the GPT doesn't work, option 1 is what? Give more examples. Option 2 is what? Highlight the features. Option 3 is what? Explain your logic. If you try all this, still not working, what do? We still have more options. It's called a soft tuning. So what does soft tuning means? So you look at this example. So I am Sean. You put in GPT. And decoder, we'll talk about decoder concept. Then I am Sean. It translates to Chinese. But it's bad translation because this I am is Chinese. Sean is not Chinese, right? Maybe Chinese people doesn't understand what does it mean. So we want to fine tune that. So what do you fine tune? So earlier I put I am shown natural language into GPT, but we want to fine tune this. We want to make the I am shown into a machine language, into a vector or matrix. And we put a matrix into GPT instead of using the language I am shown into GPT. And then it will give better answer. It will give the perfect translation. So why it helps? Because when you convert I am shown into the vector, you put the domain knowledge. You use the domain-specific model to do the embedding. So you convert this one to this one. You put more of the domain knowledge to convert this natural language to the matrix. So the process will help you embedding the domain knowledge in the matrix, and you get the better answer. You get the better answer. So simple example is Google BERT. So Google BERT is what? Google BERT is the embedding for everyone. So Google BERT is trained on what? Google BERT is trained on the Wikipedia, Twitter, and the book. That's how the Google BERT is trained. And we have another version. It's called what? Called FinBERT. So FinBERT is trained on what? FinBERT is trained annual report, conference call. So it's same case here. If you just using the I am shown here, and then it just the GPT doesn't get the finance knowledge, just get the conventional vectors. But if you use the FinBERT to convert I am shown into a vector, and then the information, the matrix here will have the information about I am shown, also about finance information. And then this vector has more information than I am shown. And then you give the GPT, GPT will give the right answer. So basically, you manually just put the domain knowledge into the embedding process and use the embedding process to convert to I am shown. So this is so basically a metaphor here is if you just use the cheat sheet, you use the cheat sheet. You use the cheat sheet to take an exam, right? Or you convert the cheat sheet into some machine language, and when you do the converting process, you put the domain knowledge in the embedding process, and then the machine can take the cheat sheet better than the original natural language form. So this is another prompt engineering method. So if it's still not good, what do? If it's still not good, you have to do something else. You have to give the feedback. You tell GPT. So if the GPT is still not doing good, GPT will tell you, you can tell GPT, you are still wrong. You explain the reason why GPT is wrong. So you give the feedback to GPT. GPT will take it and improve it. And we have more exercise on that. So the kind of reinforced feedback will do that. We'll do that. So let me so this is the reinforced learning. You can see that the GPT will give the answers, and you can rate the answers and give the GPT the feedback which one is good, which is bad, and kind of the feedback you give the GPT will also help. So let me summarize. Like for the prompt engineering, what do you have? So first, you can do zero shot without giving any example. Just ask GPT. If GPT give you a good answer, perfect, done. If not, you give examples. Okay? If the example is still not working, what do? You highlight the important features in your examples. If even you highlight the features, it's still working, what do? You explain how you get the answer. Instead of just give the answer 0, 1, you explain what's the reasoning, logic after you get the answer. If it's still not good, what do? You convert this natural language into a vector using domain embedding. If it's still not good, what do? You give feedback to GPT. You tell GPT, you're wrong, GPT, because this is still not climate. This is wrong. You tell GPT what is wrong. You give the feedback to GPT. If it's still not working, what do? And you have to go to the second option. We have to change the knowledge base model. Does it make sense? So if you tried all this, the GPT still cannot do the job. Your job is too difficult. If you tried all this, GPT still don't give you. What do? You have two options. One is you go to the option 2. You have to fine-tune the model. Go to the option 2, which I don't encourage you guys to do that, right? I don't encourage you guys to do the fine-tune part because it's you don't have the strength in that part. So what do? So you either go to the fine-tune part or you wait for GPT-6, GPT-7, because I believe what cannot be done today will definitely be done in the future. So if you just wait for half a year, 1 year, the same prompt will work. Trust me, okay? You run the prompt and the GPT now, it doesn't work. Wait for 1 year. You run the same prompt, it will work. So you have two options. Either wait for the new version coming out, or you do the fine tuning. Yeah, that's the beauty of the world, right? With the massive competition of the large language model. So basically, you can see the logic, right? You do the parameter tuning, and you do the so basically you do the prompt engineering first. If prompt engineering doesn't work, you have two options: either wait or tune the model. You change the parameter of the model. So let's understand how to change the parameter of the model. You have two options. Again, another two options. One is called parameter efficient tuning. Another one is fine tuning. So what's the difference between the two? The first one is you only change a small portion of the parameters in the model. The second is you change the whole parameters of the model. Of course, the second option is more costly, right? Second option is costly. But remember, if you want to do this kind of fine tuning, you need a large training sample. Don't even think about it if you don't have large training sample. The prompt engineering is beautiful because the prompt engineering, you only 2-3 examples. GPT can do this for you, right? For the prompt engineering, you don't need a large training sample. But if you want to change the parameters of the model, you have the 1 million, 500,000 sample to training sample to change the parameters because there's a billion of parameters there. Does it make sense? So you can see that if you only have very few training sample, don't even think about changing the parameter. Just do prompt engineering. Okay, that's the exercise we're about. We have a lot of exercise for you to do prompt engineering. But if you have a large training sample, you have a good programming skills, and you can do the fine tuning. And you have two options for fine tuning: parameter efficiency or change the whole model. So what is the parameter efficiency? So you can see that this is GPT-2. For GPT-2, you know the parameters. GPT-3 at 3.5, you don't know it anymore. So OpenAI stopped disclosing the parameters in the earlier version. But you know the parameters in the Llama and the GPT. So you can fine-tune the model. So what does the parameter efficient tuning means? You can see here, this is the older parameters in GPT. So what you do is you want to add two parameters in to attach to the older model. And you only tune these two parameters. It's called a prefix parameter efficient tuning. What does that mean is let's say this is a econ PhD. You don't want to change the econ PhD too much. You just ask an econ PhD to take 2 elective courses. That's called the parameter efficient tuning. So basically, it's still the econ PhD, still econ PhD. You don't want to change their knowledge base. You just add 2 parameters. And then these 2 parameters will be accounting specific. So that's the parameter efficient tuning. I hope that makes sense for of you guys. So basically, so you can see that you don't change the whole parameter of the model. You just add 2 parameters, and you fine tune the 2 models, 2 parameters. You fine tune 2 parameters. You make a 1 and a 2 to be accounting specific. So it's like econ PhD, take accounting elective, and then you make the econ PhD to take a CPA exam, right? That's the parameter efficient tuning. So what is the fine tuning? Fine tuning is you change everything. If you change it from 3 to 15, you change all the parameters of the model. That's the whole tuning. That's the fine tuning. Of course, like I said, I rank the options by cost, right? Of course, change it. If you change the 1 and 2, do the job. Just do it. But if you take electives, still cannot do the job. You have to change the whole parameters. So you can see that the flow we have. You first do what? You first do prompt engineering. So you first do cheat sheet approach. First do cheat sheet. If cheat sheet not working, what do? You do the parameter efficient tuning. You ask the PhD, econ PhD, take 2 electives. If it's still not working, the econ PhD has to do an accounting PhD. So that's the cost, right? Cost increase, right? That's the cost increase. So another way is which model we should use. So let's give a very simple summarize. So I would say you always use prompt engineering because it's easy, right? You also use prompt engineering easy, but it's easy with minimum effort and minimum coding experience. But the bad thing about prompt engineering is it highly depends on the performance of the model. If the model is smart, prompt engineering will work. If the model is not smart, prompt engineering will not work. So think about if you give a cheat sheet to a middle school student to take an exam to CPA, it will never work. Regarding how many cheat sheets you give the middle school students, the middle school students will not pass the CPA exam. So the prompt engineering depends on the performance of the model. But the good thing for you guys is the model become more and more sophisticated. So that's why prompt engineering start working very well, right? So what is parameter tuning means, it's more costly, right? It's more costly. So, but it requires what? It requires computational power, and it requires large training sample. So that's why I always ask you guys to do the prompt engineering cheat sheet approach first. If it's not working, and you consider about parameter efficient tuning or full tuning. So you can see that. And I want to warn you guys about privacy issue. What does that mean is, if you do prompt engineering, if you use ChatGPT, all the information you give to GPT, they will take it. So if it's sensitive data, for example, if you are working with sensitive data like a health record, like your income level and your private information, bank account, if you use that with GPT will take information. They will know what you are doing. So how to prevent that? How do your privacy? So what you can do is you can use open source model like a Llama. So Llama, you can download the Llama into your local computer, and then every information you feed the Llama stays local. Versus GPT, it's not open source. So any prompt you give GPT, they will take it. They can use it. They may use it. They may not use it. I don't know. But if your privacy issue is a concern, you have to use the open source model. Like Llama is the best so far. So basically, so depends on whether you have a privacy issue, right? So if you have a sensitive information, your bank account, you have some secret you don't want other people know, you give to GPT will take it. People will take it. But if you use Llama, you can put the Llama in your local computer and everything stays in local. So you have your privacy. Right? But you can see that, so Llama is very close to GPT, right? So GPT is slightly better than Llama, but Llama is catching up. So this is good. We have a free option and we have a privacy, right? We have a privacy. So this is this is summarize the point I was talking about. So when you do the large language model, so you can see that I can tell you 5-6 years ago, what did we do? So let's say if you want to 5-6 years ago, if you want to do the you guys going back to the earlier example, if I want to classify whether it's climate related, unclimate related. So if I do 5-6 years ago, I told you what my step. My step one is first find the keywords. What is the climate keywords? What is non-climate non-keywords? So I find the climate keywords, and then we have to tokenize the sentence, and we have to do the kind of lemmatization of each word. So much steps. 5-6 years ago, we have to do the textual analysis. But right now, what do? One line. You just ask Llama or GPT, tell me, is 1 or 0? So world become much easier, right? Like 5-6 years ago, I have to find the keywords. I have to tokenize them. I have to lemmatize the words. I have to do a lot of pre-process for the text data, and then identify the climate-related sentence, and I have errors. But right now, what do? You just give the sentence to the GPT. GPT tell you this is 1 or 0. So the world become much more friendly. But remember one thing: it's become friendly to you and to everything else. So 6 years ago, because of the technology barrier, I'm one of a few people can do the textual analysis, right? So basically, I can calculate a variable. A lot of people cannot. But now, everyone can calculate a variable, right? So this is an interesting game. The things become easy, not just to you, to everyone. So, but I want you guys, people who sit in the room, you will be the one can master this large language model. So you will have the advantage to use a large language model to calculate variables to do textual analysis. But you can see that the history, you guys have witnessed the history, right? 5-6 years ago, we have to tune the model. We have to do so many complicated stuff to calculate the textual variables. Now become much easier. Even become easier, you have to still to know what is prompt engineering, what is the parameter efficient tuning, what is the full tuning. You have to know this concept in order to make things right? I want you guys to be the first couple of business students, know how to use this large language model. And we also have we just sit down today, we have a lot of exercise for you guys to understand all these concepts.